Let's say we have this function y equal to x raised to the power 3 all over 3, and the plan here is to find the derivative of this function. So we'll just say the y all over dx is equal to find the derivative, I'll just take the power, use it to multiply x there, which will give us 3 x, subtract 1 from the power, you would have 2. 3 minus 1 gives us 2, then divided by our 3. 3 cancels 3, and this gives us the y all over dx is equal to x raised to the power 2. It means the derivative of x raised to the power 3 all over 3, that's the derivative of this function here, is equal to x squared. But you see, sometimes you might want to find the function that has this particular derivative, and let's say we were just given the derivative dy all over dx equal to x squared, and you are asked to find the function that has this particular derivative. How do we go about that? Now that leads us to what we call antiderivative. Initially we found the derivative of this function and we got our final result as x squared. So the question is, how do we get the function? Let's say we want to get the function back. All we have is derivative. How do we get the function back? Now the original function for this derivative is called antiderivative. Alright, now there's a standard way of finding antiderivative. Let's say we have this derivative x squared and we're asked to find the antiderivative. All you need to do is to add 1 to the power, okay, then divide this function here by the same power, 2 plus 1, and this will give us x raised to the power 3 all over 3. Now you see, this here is just the same thing as what we have here. I just explained how you can find the antiderivative of a particular derivative. You know, we have y here as equal to x raised to the power 3 all over 3. That's our initial function. But what if we have an initial function as y equal to x raised to the power 3 all over 3 plus 5? Now if I differentiate this, I'll get the y all over dx is equal to x squared plus, 5 is a constant, so it means the final result will be x squared. Now you see, I differentiated x raised to the power 3 all over 3 plus 5. I got this as my result. I differentiated x raised to the power 3 all over 3. I got this as the result. Even if I differentiate, let's say we have y equal to x raised to the power 3 all over 3 plus 7, for example, I'll still get the y all over dx is equal to x squared, because 7 is a constant. So you can see from this that this here, this x raised to the power 3 all over 3 plus 5, you see that x raised to the power 3 all over 3 and x raised to the power 3 all over 3 plus 7 are all antiderivatives of x raised to the power 2. Now because of this interesting realization, anytime you find the antiderivative of any derivative, you should always add the arbitrary constant to your final result. So let's say we have this derivative as the y dx is equal to x squared, and you're asked to find the antiderivative. That means you say y is equal to add 1 to the power, divide this by the power, 2 plus 1, because you don't know what the arbitrary constant is. You just add c to represent the arbitrary constant. This is the arbitrary constant for this antiderivative. This is the arbitrary constant. This is 0 here. 0 is the arbitrary constant for this, for that antiderivative there. Always add the arbitrary constant. This will be y is equal to x raised to the power 3 all over 3 plus c. Okay, so c can be anything. C can be 0, c can be 1, c can be 2, can be 3. It's very important you add your arbitrary constant. So the process of finding antiderivatives is called integration. Integration is the process of finding antiderivatives. I'll leave this here. In the subsequent videos we'll go deeper on evaluating antiderivatives.